Hello, thank you. Good afternoon, ladies and gentlemen, Datuk. And I welcome you to our presentation, which relates to development of our own electric bus by Malaysians, for Malaysians. So before I start my presentation, let's see what the video has to say about the product. Thank you.
The idea is simple. Completely eradicate the use of diesel buses in Malaysian cities. Over 1.2 million people in Malaysian cities travel by bus every day. Buses are the veins of the public transport system, reaching offices, schools and feeding trains. But in the present state, they are costly to run, uncomfortable and polluting. Imagine a world free of fuel emissions and vehicles that run solely on green energy. It's all possible now with EB1M. The Electric Bus One Malaysia is a revolution in Malaysian public transport. Designed and built by Malaysians for Malaysians, it is an eco-friendly solution for moving people. The idea is simple. Completely eradicate the use of diesel buses in Malaysian cities and replace them with green, efficient electric buses. This is EB1M. It's a low-floor bus with a 260 kilowatt-hour energy pack, two-wheel hub motors and a smart supervisory control system with intelligent driver assist, all packed into one strong and robust chassis. A well-tested and proven low-floor electric axle is used in EB1M. This has enabled the engineers to build the bus lower to the ground so that you can get on and off the bus easily. The EB1M is the first bus with a non-metal chassis in Asia. The body of the bus is a single-piece structure made of carbon, Kevlar and E-glass composites. This unique structure ensures a strong and sturdy body, which makes the ride on EB1M safe and comfy. Unlike metal chassis, which requires refurbishing after 12 years, the composite structure will be fit as a fiddle for 20 years. Buses, like any other vehicle, are bound to get stuck in traffic. Equipped with EDA, the Intelligent Driver Assist System, the EB1M can now inform you about the arrival of the next bus to a particular bus station. This is done using GPS-assisted route monitoring system and delivered via an app on your smartphone. So instead of wasting time waiting for the bus, you can now do the things that matter to you and still be on time to catch the bus. After serving the public, the EB1M returns to the base for a quick charge and gets ready to run for another 200 kilometers. Besides being eco-friendly and time-friendly, the EB1M is wallet-friendly too. With the dependency on diesel removed, and with minimal moving parts, the cost of operating an electric bus is only one-third the cost of running its inefficient and outdated cousin. The EB1M also saves a whopping 400 million ringgit per year of taxpayers' money by removing the need for the government to subsidize diesel for city buses. The future of vehicles running solely on green energy begins now. Malaysia and EB1M are at the forefront of this idea in developing a commercially viable electric bus. EB1M, it's more than just a bus. It's an urban mobility solution designed by Malaysians for Malaysians.
Okay, thank you. That's the tagline, designed by Malaysians for Malaysians. You have buses running, electric bus running in other countries, but the idea of our company is to develop something for Malaysians by Malaysians. Okay, let us go through the presentation and then I'll explain what this project is about. Okay, it's a revolution in Malaysian public transport. And why do we need an electric bus? The reason, as stated, is it reduces emission in city center. There's zero emission with an electric bus. It reduces noise pollution because there's no engine sound and gearbox sound and mechanical parts moving. It reduces cost of operation, which I will explain later. What is it about? It's basically reducing by almost 70% of your cost of operations. Reduce government expenses in the terms of diesel subsidies. No diesel expenses anymore for the operator, so if there is an increase in diesel price, they won't be affected too much. And less moving parts, less mechanical parts, less maintenance. Okay, when I say about cost saving, a typical diesel bus, it takes for a 200 kilometer, where the operator at the moment pays at 148, or probably now with the increase could be 158. So it costs them average 150 ringgit a day to run for a 200 kilometer trip around KL. But with the electric bus, with the same mileage of 200 kilometers, and our technology is consuming an average of 1.3 kilowatt an hour, so it consumes 260 kilowatt an hour a day. So if you use midnight charge, that means off-peak rates, because this bus is designed to travel the whole day, and then when it comes back to the depot, it will use the nighttime charging, which is a cheaper rate. So it only costs 50 ringgit for the whole 200 kilometers. So you can see the difference between the diesel and the electric bus. So there's a lot, there's almost, I think, 70% savings. So if you talk about lifespan cost, diesel bus is anywhere cheaper than an electric bus. Anywhere in the world, electric bus costs more. Reason being, the battery cost is still expensive now, but in the future it will still go down. So over a lifespan, a period of 12 years, you see there's still a saving, but considering the diesel price don't go up that tremendous. But we did some calculation on the difference of the diesel increase and also electricity increase. So you can see there's still a savings of almost 80 over 1,000 and could be more, because I believe the diesel price will go up further. So on the government subsidy, government spends a lot of subsidies on diesel. So by eliminating diesel for city buses in the future, at the moment I think there's around 9,000, 10,000 buses running in Malaysia, city buses. So if you talk about the consumption of 200 kilometers, so there's a subsidy of almost 500 million a year. So that's a lot of money. Okay. So we came out with this idea of developing an electric bus, a local developed electric bus using proven technology by our technology provider like ZF and Siemens and whoever is supplying the batteries and things like that. So our team came out with this idea of developing an electric city bus, reason being it's easier to implement a city bus because the charging infrastructure, you can set it up at the depot, so it costs less. So we came up with some idea of the concept. This design is developed from scratch. Okay, and it goes along with certain proven technology. So design of the mechanical of the bus, of how it looks like, is done from scratch. So we came up with some concepts, and then we have some so-called ID rendering of the design. And this is the specification of the bus. This bus is designed for local city operators, so it has to meet to the JPJ standard and specification. And JPJ follows the UNECE ruling, which is the United Nations Economic Commission for Europe. JPJ adopts that ruling. So we have to follow with that specification, and we design this to the operator's needs, which is, you know, the normal local operator's needs. So if you see, we can't change much in the electric bus. So it's still the same. Seating capacity, I think, is 23, is allowed for more standing room. So the total passenger capacity, I think, is around 63 or 65. And the rest, there's the energy, which is we are using a lithium-based battery. It consumes 260 kilowatt, 600 volt, 400 amp for a 200 kilometer range. And we need a 3 hours charging time to fully charge the battery. Okay. And then the unique part about this design is that this is the first time in this region that we are using a complete composite monocoque structure for the bus. There's no metal chassis, there's no metal body, there's no rusting, there's no welding anymore in the future. So it's a full composite bus. We are using composite to make it lighter to offset against the battery weight. Okay. The key technologies that we are using is the unique ZF electric wheel hub motor. It's a water-cooled motor with 10,000 Newton meters of power. A lightweight composite monocoque chassis. A low floor allows faster point-to-point because this bus doesn't have an engine and doesn't have a gearbox, so it can go low floor from front to the back. So this is the advantage. And then we have the efficient battery packs and BMS. The BMS is going to be designed by us locally. Of course, battery packs might come from China or anywhere initially. And then we have with this wheel axle a regenerative braking energy recovery system. We are developing this into our system. The power consumption, like I say, is between 1.1 to 1.5 kilowatt an hour. And then you have the intelligent driver assist, which is a unique part of this bus. It's a smart bus. It's using electronics, processors, and things like that, which can be linked later to the GPS system and the fleet management system and everything. And then you have the normal anti-lock braking system and adaptive braking light. The intelligent driver assist, you have the interactive touchscreen instrument panel. You can see this at our booth. In the future, it will have real-time GPS-assisted route monitoring system, advanced parameter telemetry, data logging systems, and all this will be linked to any operator fleet management system. So this is the unique part of the bus, which is the composite monocoque chassis. We are using composite, so there will be no more welding in the future, and it has a longer lifespan, and it's tough. If you see at the picture there, there's a car of a typical American car, which is around 2 tons, and the bus is static. The bus goes at around 60 to 70 miles an hour, and you can see that there's nothing damage done to the bus. Okay. Why composite? You can see the difference between composite and the steel chassis and aluminum. It has a longer lifespan. It's cheaper in the long run. Of course, when you use composite body, you need the first mold. That is the high investment cost. But later, once you amortize it over 1,000 units and things like that, it makes sense. And you can see there's a lot of difference between the cost, which might cost, the body will cost us around 100,000 ringgit versus the normal conventional metal chassis and body. So you have, like I say, the low floor, which goes from the front to the back. There will be a race at the back to accommodate some batteries, that's all. But you don't see the race like the normal diesel bus that you see today. So this is the layout, roughly, how it looks like in the future. So we have started this project from feasibility study from 2011. And then from the feasibility study, we developed some specs and presented to certain operators, and they liked the idea. And then we came out with the design and development in 2012. And then this year, we have already got most of the critical components down. You can view them at our booth under the IRIS banner. Okay, so by starting next month, we'll be building the prototype per se and doing all the simulations, the electronics and everything. And then the composite body will come towards the first quarter of next year. Then we will assemble this bus, and hopefully by next year we can get it on the road for testing and certification. And then we can have the production rollout by 2015. So this is just not a R&D project, but it's R&D development for commercialization. So I can show you the next slide, which is what we have been doing for the last 2.5 years. The team, the idea, and some of the prototype build activity at our facility in Taman Shamelin. Okay. Sorry, the music is not here again. Okay, it's coming. Engineers working. You can see some of them at the back with the black shirt. A team of young engineers. And we work with our technology partners, our consultants. Designs, drawings, everything was done in-house from scratch. The engineering structure is being analyzed in-house. This is our CAD design. Facade of the bus, the front and the back, can be changed even if it is a permanent mold. You know, so we can suit to any operator's needs of their facelift and things like that. This is our assembly facility. There's the electronic components that's being put. There's our electronic geek, Billy. And that's our head of engineering, Mr. Ganesan. The team. So this is already the prototype build stage we are going through now. This is not the chassis, this is just a jig. Okay. See our simulation starting with the wheel motor axle. There's a big motor inside here, inside the wheel hub. Okay, it's been simulated now, and it's water cooled. You can see the radiator at the back. And that's our electronic team working together to put the thing. It's turning, I mean, it's making sense. This was the most challenging part, whether our control will talk to the motor and the controller. So this, we have gone through the first challenge. Okay. I guess that's all.